Hello dudes, welcome to tech2.com. So today we are going to study a very hot topic, not just for GATE syllabus, but also for the user point of view, practical point of view. So the topic is normalization. So what is normalization? Normalization is basically breaking up the table or a relation into multiple tables so that we can reduce redundancy and we can make it more efficient, error free. Let's start with an example. Here we have a database of student in which we are storing student ID, name and department name. Now let's say there is a student of ID 1, name is S1 and department is CSE. Well, so we have 5 students here, S1 to S5, and they have corresponding departments. Now up to this it is fine. Okay. Now let's suppose we have to store another entry here, okay, in our database, and this is our database. We don't have any other table right now. We are starting our database, right? So we are starting with student. Now we have to store the HOD of the departments also. So now what we will do, we will do some little modification in this table. We will add another column or another attribute, that is HOD, and we will fill up the entries that Professor A is HOD of CSE, Professor B is HOD of EC, Professor A is again HOD of CSE, and similarly we will keep on filling up. So now there is a point of observation that whenever there is a student of computer science, whenever there is a computer science student, this entry is repeating: CSE Professor A, CSE Professor A, CSE Professor A, right? So don't you think this is a redundancy? Because every time when you enter a CSE student, you will enter the branch CSE and then you will write Professor A, CSE Professor A, right? So similarly, this is a redundancy in our database. Now let's make it worse. So we have to store phone number of the department. Here we have another column which is phone number. Now situation becomes worst because we have to again store phone number of the department every time the department a new student is added. Let's say here in this case, every time a CSE student comes, you have to enter Professor A and then 32272, 32272, 32272, right? So this is complete redundancy. The same thing we are storing again and again, and this will increase the size of our database. Okay, so this is redundancy and this is what we have to remove. Now let's say the phone number is being changed. So computer science department phone number we are changing and it is now 32222. Okay, more symmetric phone number. It's not just changed at one place. You have to find out all the computer science department students and corresponding phone number you have to change. This will be updated, this will be updated, right? So all will be updated: 3222222, 32222, right? So everywhere you have to update. Similarly, in case of deletion, if you want to delete an entry or a phone number or something, you will have to delete everywhere. Okay, so this updation and deletion, okay, and even if you are inserting a new column, this insertion, everything is a redundant process here. Okay, everything, all the processes will take much time and this database is completely inefficient. So that's where normalization comes into picture. Normalization breaks this table into two tables. Let's see what it does. The previous students table is broken into two different tables, which is one is student and another one is department. So if you see here, we are just keeping record of the student's department ID, okay, and we maintain this as a foreign key. Okay, in this is a foreign, department is a foreign key of student table which is referring to department table. So what do we do whenever we need the details of department? We refer to the department table. Now if you see, the redundancy is minimized, that we are just storing the student's department ID and we are separately storing this department's information, that Professor A is HOD and this is the phone number. Now let's consider a updation case. Let's say we have to update the phone number of computer science department. Now you just need to go to computer science and update it to 2222. Okay, no redundant updation, just at single place. Similarly, if you want to delete some record, you will delete at single place. Okay, and no need to store storage of this computer science details again and again. Just at one place we are storing this computer science detail. So this is how we proceed for normalization. If you see, there is a point to notice that even after normalization we are storing this CSE two times, three times. So for each student we are storing this CSE again. So here again, if you somebody can say that you are storing three times this CSE, and this is also a case of redundancy. So yes, the answer is, in relational database model we cannot remove redundancy. We can minimize, but we cannot remove. Okay, so now there is a good practice in general. What we do is, rather than storing ID as, let's say, computer science, CSE, EC and all, for each department and student we keep ID as numeric values, that is 1, 2, 3. Okay, so let's say for this department ID, we will, rather than this CSE and all, we will keep ID as 1, 2, 3 and so on. Okay, and this will be auto increment. It will be incremented automatically whenever a new record is inserted into this table. And now here, rather than storing this CSE entire text, we will just store 1, 1, 1. This will be 2, this will be 3. Okay, so the value which we have to store, somehow we can decrease, but we cannot remove redundancy. Okay, so this is all about normalization, the basics of normalization. Now we will study the normalization process and the various normal form one by one. So let's get started. Thanks for watching.